Welcome to Blockchain Security Series, the podcast where the future of Web3 security unfolds. Presented by pablito.eth.
Hello and welcome. I am Pablo Sabbatella, your guide through the intricate and evolving world of blockchain security. Each episode we dive deep into the heart of Web3, bringing you face-to-face with the pioneers and key players shaping the blockchain security ecosystem. Presented by BlockFans. Well, hello everybody. Welcome to a new episode of Blockchain Security Series. Today we have Ryan Lackey, Chief Security Officer at Evertas, and I am pablito.eth, Pablo Sabbatella, Head of Security Research at BlockFans and member of Sealand. So, Ryan, how are you? How's everything?
That's very good.
Well, not so long time since I've seen you.
Yeah, it's been a couple of months since we met at the LebBitConf in Buenos Aires last year in November. That was great, and then we've talked a couple times since then. I think, didn't we meet up in Turkey afterwards and in Istanbul?
Yeah, we met at LebBitConf in Buenos Aires, and then we tried to meet in Turkey for DevCon, but we couldn't meet there.
Okay. I travel to maybe nice 30 conferences a year right now, so it's pretty fun.
What conference are you right now in?
Right now I'm in Toronto for Real World Crypto, which is one of my favorite conferences. It's a very good cryptography conference that also focuses on the deployment issues of cryptography. So WhatsApp talks about how they do their large-scale deployment of end-to-end device negotiation, things like that, as well as emerging crypto protocols. So it's a very diverse conference with a lot of people. And it started maybe 7 or 8 years ago, and I've been to almost all of them.
Nice. What would you say that are your preferred security or crypto conferences that you go? The 3 or 4 favorite for you?
Yeah, there's a whole lot of them that I really like, but probably Ethereum DevCon for the crypto community is the best anchor event because it has a lot of other side events. A lot of these conferences are really good because they have a lot of side events that are really relevant. ETH Denver and ETHCC in Europe are the two community Ethereum events that also are very interesting. I like Ethereum, but I'm not strictly an Ethereum person, so I like to go to a lot of the stuff around it. And then Zcash, the Zcon series of conferences that they ran were always really good. LaBitConf and other events that are sort of regional focused are also very interesting. And there's a lot of stuff happening in Asia now that's really exciting. I think the ideas like Korea Blockchain Week, getting to see new countries. So the first year or two of each conference is very interesting. And then there are conferences that every year are worth attending. So there's a lot of different conferences that are good.
So when is Zcash happening this year? I didn't know about that conference, but now I want to know.
Yeah, Zcash this year is not happening in person. They had some changes in leadership at their foundation. We can talk about crypto foundations later. They had some changes in leadership, and they're changing how things work. A lot of the Zcash people are here. They had an earlier event for insider people earlier, but they're going to have a really big event next year, which will be great. And there's also ZK Summit, which is a series. There's one in Athens this year, I think on the 11th of May or some month that's coming up soon. And there's a lot of conferences that are ZK specific now. Obviously, Starkware has a lot of events and people like that. So there's a lot of different things. The interesting thing, what I do now in insurance, is we get to follow everything in the space because any sort of potential risk is relevant to us. So I get to go to pretty much anything that is sort of tangentially related. And then, of course, financial cryptography is amazing. The one I just went to in Curacao, because that conference is held on a tropical island every year. Yeah, it's quite fun.
That's nice. So you're basically living in in different hotels for the whole year and going to conference.
Yeah, I live in San Juan, Puerto Rico, but when I'm not home, I'm traveling and going to conferences at hotels. So,
that's good, and that's how I met you. So I remember from the first time I met you when you told me about your beginnings in crypto, your beginnings in computer security. I was amazed by your story. So I want you to go into that. How did you start in this world? And
sure.
And one of the most interesting things is when, right?
Yeah. Yeah, in the late 1980s, when I was about 10 years old, I first got access to the internet. There was a program where some people that were doing education research at Stanford University did a gifted program, and they took the instructors from there and they brought them out to a school in suburban Philadelphia where I lived. And they set up a special program and they gave internet access and other really advanced stuff. We had access to the computerized Legos, the Lego Mindstorms when they were still a prototype, all sorts of cool stuff like that, like a decade before everyone else had them, and got to play around with that. It was really nice. And I got to learn how to program early Macintosh stuff using like HyperCard and Hypertext and then Smalltalk and some other languages. I then got access to, I took a university class. There's a thing in the US where you can take the SAT test early. And if you take it and you get a high enough score, you get to take a college class. So I was 12 years old and a local university let me take a computer science class, the first computer science class at night, which was really fun. Not so much because learning Pascal and programming was all that exciting, but because they had VMS computers that were internet connected in 1992. And I got an account on this machine, and I had basically unlimited access to the internet from like age 13 onwards. And it was amazing. I had to fight to maintain that. I had to sort of like, they had a dial-in server, and the way the dial-in server worked, it had an authentication database that was actually separate from the computer database. So when they delete your computer account, your account still stays active in the LAT server, which was the local dial-up server. So I was able to maintain access for years, even though they didn't really intend me to. And it was a fun game of like cat and mouse to keep internet access. But yeah, I had internet access from really early on. I got to read the Cycrypt Usenet group, which was one of the good forums for discussing cryptography. I emailed people like Ross Anderson, the professor in the UK, who was developing a lot of the early ciphers, that one of the contenders to be AAS and a top researcher, asked him about some of his research. I followed all this stuff, and I was like an early teenager, which was really nice. And then the most important thing is I found the Cypherpunks mailing list, which was this mailing list that was created by Eric Hughes, John Gilmore, and had a lot of people like Tim May and other people on this list. And it was really where all the ideas that are currently being deployed using cryptocurrency were discussed about 2 decades before they were really possible to build. The interesting thing about all the stuff that we're building today is a lot of it was actually developed. The academic part of it was in the late 70s, early 1980s. David Chaum created blinded digital electronic cash, which is basically Bitcoin but centralized. It patented it in 1982. And then a lot of the public key cryptography stuff was a couple of years before that. So this stuff has existed as possible, like theoretically for a long time, but just getting it to the point where building software, deploying it, having mobile phones, things like that makes all this stuff possible. And that's taken decades to build. So it's a very exciting path to see. And that list was amazing because we talked about all the things that would be possible if we had this thing, if we had anonymous electronic cash deployed at scale, like what would happen. There'd be anonymous remailers, there'd be digital markets, there'd be all this stuff. And almost all those predictions have been largely borne out as true.
And you, when you began all this journey, you had like a project, or you started working in a crypto project, like in 1993 or something like that?
Yeah, a little bit. So one of the things I did is I ran a mailing list archive for the mailing list, starting in maybe 95. Okay. And there was this idea that Professor Anderson had called eternity servers, which is basically sort of like Filecoin, basically. I think would be the current version of it, where you have compute, storage, and bandwidth, and you have tokens that are used to pay for it. And people were building different implementations. Adam Back created one implementation of it, currently the Blockstream guy, and a couple other people created implementations. I created one. It wasn't very good. I also worked with some other people to create a patent evading version of Chaumian blinded tokens. The biggest thing I worked on was trying to take this thing that was patented. It was covered by the RSA patents. It was covered by ITAR, which is the International Traffic in Arms Regulations, where you can't export crypto from the United States. And then also Chaum and RSA patents all covered this thing. So one of the things I did, so I dropped out of high school to go to MIT. I went to MIT early, and I was working on some of this stuff. I didn't have enough money to pay for tuition, so I was working a little bit on the side for an audio company and some other stuff like that. But I presented at a conference, and I was at a conference along with Ian Grigg, who's the guy that went on to start R3. We both presented basically things you could build on top of existing things that existed. There was a thing called eGold, which was a gold-backed digital currency where they kept a big vault that had lots of gold bars and certificates for gold bars and things like that. And they issued basically like an account-based gold system. We built an anonymous electronic cash system on top of that gold system. Those people were in the audience, and they said, if you guys are willing to build that thing that you just talked about, we'll give you $200,000 in cash if you'll start it on Monday. And it was a very easy choice for me. So I bought a one-way ticket to the Caribbean and started building it that Monday. And it was pretty fun. So it was basically a digital currency, an anonymous digital electronic cash system backed fully by gold, built in the late 1990s, which was pretty fun. Unfortunately, the underlying currency did not really do KYC up to the standards that the feds wanted. And the people involved in that, I left for a little while, for like 3 or 4 weeks. And then I left for a little bit longer just because I was kind of bored of being in the Caribbean. It was like a little island that had 6,000 people, and I was 18 years old, and it was not really a very exciting place to be. But I found out 10 years later that if I had stayed another couple of days, I would have been included in the prosecution of all the people involved in that project, and I was not. So yeah, because they got in trouble for not doing KYC. It ended up not serving any jail time, but it was pretty bad for them. And I found out from the U.S. attorney who's now in private practice, that I could have gotten in trouble for that. So yeah, an exciting project. But that was kind of my first big introduction to this stuff, like moving to a Caribbean island, working on stuff. Because one of the things was we couldn't export the stuff from the United States legally, so I could work on it. I could write an academic paper and describe like how I would build something, upload it to the internet, and as long as at least 50 people in the world had access to that paper, it was considered publishing, which is covered by the First Amendment. And then a Dutch citizen sitting next to me could download that paper, implement it, and then I could look at it and say, yes, that's good. And that let us make a non-US version of it. It's the same way that like PGP got exported. They wrote it into a book, and they exported the book, and they scanned the book in, and they ran the code that way. So yeah, it was a pretty fun sort of like legal hack around it. The tricky part is we did this from a little Caribbean island, and this little Caribbean island, Anguilla, decided that we were stealing jobs from local people. So we all got our visas canceled. It was like a political thing, and we got our visas canceled. So yeah. Yeah. So that was sort of the thing that led me into the next project, which is I wanted to find a place where I could build electronic cash and never get kicked out of that country by the government again. And so I had some friends who had also lived in this little island before I lived there. And we found a book called How to Start Your Own Country by Leo Strauss. It was a little pamphlet from this weird publisher called Lumpanics. And it had all these projects. Like there was a reef in the Caribbean where they tried to build structures on top of it called like Atlantis. There's a few other projects like that. One of these projects was called Sealand. It was a World War II anti-aircraft platform that the British had built in the North Sea and sort of abandoned after the war. It was sitting out in, at the time, international waters, and they were doing all sorts of pirate radio stuff where you weren't allowed to do commercial radio from the UK. So people would take little boats and they'd go out farther and farther. They'd run their radio broadcasters from those boats. So they could run pop music and they could run advertisements and things like that. The British started shutting that down closer and closer to shore. So people kept going farther and farther out. And then people found this place, and it was actually international waters, territory that was unclaimed by anybody. So they went on and they claimed it, and they called it its own country called Sealand, which was interesting. And that happened in like 1967. And they were able to keep the place continuously since then. There was one issue where some like German people took it over, and then they came back and took it back from them. But basically the British didn't do anything about it. And they did some minor things that sort of were de facto recognition for it by like letting them use international postcodes and things like that. And in 1999, my friends found this place from this book, and we wrote to them and decided we were going to run internet hosting from this place. So we had an agreement to buy the island and turn it into a data center to host casinos and stock market newsletters, electronic cash, all sorts of crazy stuff like that. And it was pretty successful. It was on the cover of Wired in like June 2000. And we raised a couple $1 million. We were going to raise $5 million, but the problem with our timing is we did this right at the peak of the dot-com boom, and then the dot-com stuff collapsed. So we had a cost structure that was basically $3,000 for 1 megabit of bandwidth as our cost, and that was close to what the commercial prices were at the time. But then as soon as the dot-com collapse happened, the price went down to like 20, but our cost stayed the same. So we were really, really expensive compared to everything else, and we sort of ran out of money. And it got so bad that like we ran out of money to the point where we could afford food, but we couldn't afford anything else. So I was stuck living out on that place continuously for like 6 months at a time. And it's a little 5,000 square foot tiny platform in the North Sea with like one other person, like a security guard and generator mechanic. And it was very exciting. So that was where I was when the whole 9/11 thing happened. And I saw that it would be very bad to run a privacy hosting center offering a lot of hosting stuff right after that. So it sort of wound down after that. But I did that. And then I moved back to the US and did some other projects. Like we were doing one of those country code domain names, just like .ai. Anguilla now makes 5% of their GDP off of selling AI domain names. There's another place in the Pacific that was doing the same thing. And then kind of crazy story, but I broke up with a girl and I wanted to get as far away from San Francisco as possible from that after that. And I had some friends who were on this blogging site called LiveJournal that were like Iraqi expats. And this was in 2003. And they wanted to move to Iraq after the US got rid of Saddam and said, we're going to set up the first internet exchange in Baghdad. So it'll be a place for all these ISPs to peer and everything else. Because they thought, because Saddam was gone, the country is going to be so safe and so happy and everyone's going to move back. And basically there'd be so many people starting ISPs that we have to peer them in Baghdad, of course. So I moved there, and I flew there as like a civilian, and I moved and lived in a house out in Baghdad, and we were setting up like a peering site, selling satellite internet access to people. And the narrator voice would be like, that was not what happened. This country basically fell into like a civil war sort of after the U.S. invaded, and it was pretty bad. And I was living out in this little villa out in the dangerous part of Iraq, driving around to places setting up satellite internet, which was an exciting career. And I ended up moving on to a military base and doing more stuff with military contracts. But I did that for most of the rest of the next like 5 or 6 years in Afghanistan, Iraq, places like that. It was interesting to me because I'd never done any stuff with the U.S. government before. And I'd always thought of the U.S. government as like this enemy that was sort of the thing that you try to build all the crypto stuff against. But I thought they were really competent and like one organization. The biggest thing I learned is not that they're good or bad, but that there's not one big monolithic thing. It's like lots of little separate parts that don't really cooperate with each other and don't really understand what's going on. So some parts of it are very pro-privacy. Some parts are very anti-privacy. Like the most pro-privacy people I know are actually government employees who don't want the government spying on their own personal stuff. So it's very interesting to see. And then I did that for a while. I then, sort of as that was winding down, I was thinking about what I would do next. And I'd always really been interested in hardware security. So the biggest problem with software is you have to trust hardware. Well, there's a lot of problems with software security, but one of the biggest problems is that you have to trust the underlying hardware. And most of the hardware that you run on is not really designed to be trustworthy. It's designed to be cheap. It's designed to be fast. It's designed to be reusable for various things. But there are a lot of issues with trusting hardware. If you physically have the computer in front of you and you load the software, you have some assurances there. But if you're trying to trust a cloud installation of something that you've never seen, you don't know if you're talking to a real version of it or to a simulator or whatever else. So one of the things that exists in a lot of this stuff was a lot of technology built for DRM. So things like, it was called Palladium back in the late 1990s. It then became Intel TXT, which then became Intel SGX and is now Intel TDX. So it's basically processor security technologies that can prove like what's running in a given server. I built some technology to let you use that technology to do remote attestation of a VM. So you could prove what code is running, like which Docker container or which VM image you're actually talking to, and have a way to do that. And it was a fun thing. And I did Y Combinator, the startup accelerator in the Bay Area. I did that in the class of summer 2011 with a couple of my friends that I'd met over the past 10 years. And we tried to build that. We tried to get Amazon interested. We talked to Amazon a few times, but the problem is Intel at the time had not launched SGX, the processor technology we really needed. And they said they were going to launch it like in the next generation of chips for 3 generations of chips. So it took about like 3 or 4 years before it actually shipped. It was like 3 or 4 years late. And we ended up selling the company to Cloudflare, which is one of the big DDoS mitigation network security companies, to sort of help deploy these nodes, because at the time they were building these really big nodes where you'd take a cage at a data center and you'd have trust because you had all your equipment there, but they wanted to be able to build a single server that you could deploy to a data center in an ISP, and they wanted a way that you could trust the infrastructure there. So I got to do that. I ended up being a product manager responsible for like most of the security products at Cloudflare for a couple of years, and it was a fun introduction to what the most interesting stage of a startup is, like either really, really early when it's the idea stage and building it up, or once you see that it has traction, you have users and it's growing really fast, and it goes from like 50 employees to like a couple thousand employees, and from something no one's really heard of to really successful. And I've now seen both of those stages, and it was a very good experience.
Yeah, I'm a very, very big fan of Cloudflare. I really, really like.
Yeah, I use them for a couple of projects now. They're amazing. Yeah.
Yeah, I don't remember the number exactly, but the other day I read that like 10 or 15% of internet traffic is routed by Cloudflare. Can be that
Yeah,
number?
it's pretty crazy. Yeah. And the other fun thing is there's both the customers they have, and they're also so big that when I was there, which was 2014 to 2016, it was when SSL certificates still cost a lot of money. So we started talking to Let's Encrypt and some other people about rolling out free SSL for everybody, and we were able to get that deployed. So basically the internet went from nobody had SSL, or only people had it for their shopping cart sites and things like that, to becoming basically the default for everybody within the 2-year window of time. After Snowden stuff in 2013, people understood why they wanted it, but it was still very hard to do. And then over 2 years, we made it easy to do. And then a couple of years later, the browsers made it very bad if you didn't do it. So it was maybe a 5-year transition, and I got to be there during the middle of that.
Yeah, I remember that transition. It was Universal SSL was the name.
Yeah.
I remember. Yeah, totally. I've been using Cloudflare since 2012. Yeah, I remember I had a partner that really loved it, and I started using it, and I said, okay, this is great. So, you have talked a bit about like the government, how you saw that the government works, that they do not cooperate so much or are not so organized as one would think. We're also talking about all these kind of developments that have been in crypto. What do you think about regulatory stuff, crypto? Yesterday I was thinking like I was gonna tweet something like, what's the best tool against governments, like a real firearm or cryptography, right? To open the debate. Mm-hmm. So what do you think about these technologies, regulation? Where are we going?
Yeah, I think the biggest issue with regulation right now is no one knows where we're going, because it's become both a partisan political issue in the US, like being pro or anti-crypto has become explicitly a partisan issue. And then also we have a bunch of regulators that don't understand the technology they're regulating. It's much more the case here with cryptography than it is with even regular computer security or with computing or anything else, but they don't understand that stuff. I don't think most of these people understand anything outside of basically law and traditional finance. Part of it is because they're all very old. Like the average age of the senior regulators and all these things and legislators is they're at least 50 to 60 to 70. A lot of them are in their 80s. And they're not really people that have a tech background. There's a few that have a medical background, but most people at least in the US and the regulators, and unfortunately the US does get to set, I'd say the US and the EU largely get to set the world's regulatory agenda. EU does it a few years later by putting sort of onerous restrictions in place, and the US does it earlier by which companies are allowed to do transactions and various things like that. But it's they largely set the policy, and they have some of the least informed, least competent regulators out there. And it's not all of them, but like a lot of them are. And really none of these issues are the core issues of most voters, so they don't really care about it. So no one's going to put all their effort into it. We have a few senators in the US like Wyden, who's very, very pro-privacy, but he's luckily in Oregon where he doesn't really have to compete too much for his seat, and he doesn't have a whole lot of influence. He's very, very vocal on the issue, but he's only one senator out of 100, and as a result doesn't have a lot of power. This is not something like a big economic issue where they have a lot of other constituencies to bring in and they can sort of trade votes on it. It's an issue that really exists that is more like a fundamental human right or civil right and not a economic issue for most people. The issue with crypto is that there are incumbent interests that this is a new technology that hopefully is going to make things cheaper for consumers, but is potentially going to reduce employment in the banking sector. It's going to eliminate a lot of the intermediaries, and those intermediaries do not want to be eliminated because they make a lot of money and they have a lot of votes and they make a lot of political contributions. So there are a lot of senators, so for instance, Senator Warren, who has a lot of financial industry behind her, which is ironic because she created this financial regulator. The problem with regulations is they generally tend to be in favor of the incumbents, and they do a lot of, they can put a bar so it's very hard to come into that industry, and they're very easy for the big companies to comply with. So every time there's a new regulation, it really just makes things stay the way they are. It doesn't allow innovation. And that's the unfortunate part. I do think there's a lot of issues with computer security. Like, it's crazy. I would certainly be wary of recommending a non-technical person to use cryptocurrency in any way right now. Like, it's very, very risky to do if you don't have any familiarity with stuff. There's a lot of scams and things like that. At best, maybe a really good centralized custodian that you work with, like some of the big exchanges, you might be able to work with them. But trying to explain like DeFi to somebody who barely understands how a computer works and things like that, that's going to be a very, very difficult thing. So that stuff has to be sort of behind the scenes. There has to be a very nice user interface built on top of it. We've seen that, like most people who own who trade public equities right now, at least in the US, don't know how like brokers and custodians and everything else work, but they know that they can use a retail broker like an E-Trade or Robinhood or D. Shaw, or like any of these companies, and they can work with them and use them for trading and not have to understand the mechanics behind it. But with crypto, you kind of have to understand those mechanics behind it to make things work.
So there I have a question for you. Two questions. First, yeah, I agree with you that crypto is not ready yet for mass adoption, right? I mean, just going from the basics, right? We all need to have a private key, and we need to maintain it private. That's like the first issue, right? And you said that perhaps you wouldn't recommend it for technical people, but I've been doing like lots of research on different hacks, scams, and things. And I've been seeing lots of crypto OGs, developers, people that work in security, perhaps not in operational security, getting hacked and getting totally wrecked, right? So there I have two questions. Like the first one is, the idea with crypto is that we use a system that we understand, right? To understand how it really works. Because perhaps if a person just sets up an account in a centralized exchange, it's like copying the old system, right? So what do you think that needs to happen in crypto nowadays to have a bit more of mass adoption? That's the first question. And then what's your experience regarding security for people that are target, right? Like crypto OGs or directors at different companies that perhaps are technical people, but they don't believe that they're a target, and then they finally get hacked eventually.
Yeah, as far as the promise of decentralized crypto, the nice thing about the crypto, even if you use a centralized exchange, is you can exit that centralized exchange. Right now, if you're a customer of the banking system, you don't really have an alternative to the banking system. You can't start out in the banking system and then build your own system outside of it. If you get started in crypto today, like say you bought like 0.1 Bitcoin at a major exchange today, and you hold it for a few years, and that's worth a lot of money, but maybe in a few years it'll be worth even more money. When it's worth a lot more money, you might be willing to put more effort into building infrastructure around securing it. It's much, one of the problems of security is it costs basically the same to build the system to secure a relatively small amount as a large amount. You do have different threats, but if you don't want to lose it at all, then you have to build a lot of redundancy into the system, and you might end up spending $10,000 to protect $10,000 worth of assets, which it really doesn't make any sense. So the advantage of using a centralized exchange or a centralized custodian is you have a lot of other users to share those costs with. They have a 24/7 operations team and everything else, so you get some benefits there. But really, to get the point where people can use this in a truly decentralized way, we need better platform support from the underlying operating system vendors. The problem is right now, I think Apple especially, and to some extent Google, and really any of the OS vendors, have been at best uninterested in crypto, and in a lot of cases very hostile to crypto. Like Apple for a long time wouldn't allow crypto wallets to be built in the App Store. They have secure enclaves built into the iPhone, into MacBooks, things like that are really secure. They're actually probably better than the secure elements that are found in most of the hardware crypto wallets, but they're not allowed to be used for crypto. So they're not allowed to be used for programmable application logic there for crypto wallets. Like they can't be used for some of the curves and things like that are used. So you can't run your all of your application logic inside it for all of the algorithms. You have to use some of it in the host and some of it in the secure element. And as a result, it's not the greatest experience. Plus, there's the problem of, if you were to spend $20 million to build a great software wallet right now that depended entirely on access to the Apple secure element in your phone, and then Apple pulled you off of the App Store, you'd be out of luck. So there's that. They're better now than they were a couple years ago, but they're still not quite as friendly with that as possible. So you really need good first-party support from the application vendors. If cryptocurrency were treated the same as other things in security, there probably would be an Apple wallet that would already be built into the phone. It would be used for various things, and you just have crypto within the regular Apple wallet, and it would be like a good user experience. So if they wanted to make the user experience good, they probably would be able to, and they just haven't. They've either not been interested in doing so or actively been uninterested in doing so. So that's a major issue. And a lot of this stuff is hard, and it's also evolving very quickly. So it's very, very difficult to build something that's easy for people to use if all the technology that you're building it on top of changes every couple of months, and a lot of the underlying L1s are changing all the time. I don't think any of the systems we have today are really at the point where they need to be for everyone to be using it for routine transactions all the time. So new stuff is going to have to be built, and it would be hard to build that today. There's a lot of different systems that people are proposing or that exist, and there's competition, and there's problems of like market fragmentation and everything else. So it's overall a difficult problem, both commercially and technically, to make something that really works. So I think that's why we don't really have consumer stuff at scale yet. There's also not a single killer app that has really taken over. There's certain markets, obviously the Latin American market with USDT on Tron as the most successful crypto deployment of almost any time, where the real asset there is being able to have access to a relatively stable currency to put your assets into and then make international purchases, is a very, very compelling use case. That is not a compelling use case in a place where I can open a savings account locally in dollars and earn 5% interest on my money, as well as have a easier user interface. So in certain markets it makes sense, in certain markets it doesn't make sense. And then there's a lot of interesting stuff that's possible. Like, it would be great to be able to do peer-to-peer payments, to be able to participate in DAOs, to do projects, all sorts of things like this, but they're still not, it's a lot easier to convince people to do something that they've already seen work a lot of times, and none of this stuff has been shown to work at scale for anyone for a lot of these applications yet. So once it happens, it'll be a much faster adoption, but we're starting to see a lot of stuff. One of the things that I'm most excited about is I'm not interested in art particularly at all or anything else. Like, I have no art, I own none of that stuff, but the NFT world has brought more people into the crypto community from outside that had their own interests than really any of the financial stuff for crypto has ever done. And they went through almost all the same problems that everyone else had, where they had even less of a background in computer security. Your average artist is even less into computer security than your average financial trader. And so they had to learn about how the wallet is like actually storing your thing. It's not just an account, things like that. And the user interfaces for these things had to get a lot better. So it sort of forced a lot of the industry to get better on those kind of things. And it's also privileged from a regulatory perspective because it's a free speech thing. It's much harder to go after somebody for creating free expression and creating a piece of art and selling it. Plus, people like artists. They don't really like financial traders and speculators. So it's a lot harder to go after an artist that has a large community behind them. So it's done a lot of good stuff. But yeah, there's a lot of stuff. I don't really know how it's going to go. I'm confident that it will be successful, but I don't know exactly how it will get to the point of being successful. But on the other part of that question, though, is something I know a lot more about, the threats that are sort of targeted against high-risk users. We see that not just in cryptocurrency. We see that in computer security. You see journalists that are reporting on stuff and they get targeted by nation-state malware. You see people that are even in traditional finance-related things, where I think one of the biggest wireless AP vendors, Ubiquiti, had a financial scam for, I think, $50 million. It was like $44 million, where the CEO allegedly sent mail to the CFO saying, make this wire transfer to this location, and it was all fake. And yeah, so that had to be reported in their filings. So you see that stuff happening in TradFi. So this is not specific to cryptocurrency at all. It's just high value stuff. But the crazy thing about cryptocurrency is, one, a lot of the transactions are irrevocable. Like, one time they happen and they can't be rolled back. So unlike a wire transfer, which, if it's a domestic wire transfer in some countries, usually can be at least traced and can be rolled back. But if it's a crypto transfer from point to point, you can maybe freeze it at the destination if you control the wallet at the destination. But if it's not a wallet you control, then it's very difficult to do. So you have to stop it at the exchange. And then there's a lot of other issues around cryptocurrency, where the infrastructure that's been built up around protecting traditional systems, where you have multiple signers and everything else, and personnel controls and background investigations and everything else, was not really done by a lot of the crypto projects. So they fell prey to the traditional threats that had already been addressed in traditional finance. We see a lot of this stuff. I think there's probably a few big categories of attacks that we see. We see the I'd say basic Web 2 risks, like attacks on forums that people control, like taking over the Discord admin account for somebody who runs a large project and just saying, hey, we're going to launch early, send all your funds to this location and you'll get in early. That works almost all the time and makes a lot of money. And it's very hard to defend against because Discord is like a gaming service. It's not designed to be a financial communication service. And so they didn't put a lot of protections in there. And it's actually really hard to protect things like Twitter accounts, Telegram accounts, Discord accounts, things like that, because you're really depending on the security of both the operator of those centralized services and all of the infrastructure of all of the employees that have admin access to that thing. So if somebody's personal phone is used as the recovery account for their Discord account, and you can somehow do a SIM swap on their personal cell phone, then you can take over their account. And to the Discord, it looks like a totally legitimate thing where they just sort of decide to post something and there's no reason for them to block it. So all of those risks exist, and they are pretty serious risks. The other risks that are more crypto specific, we've seen like the Oracle attacks that I guess my neighbor in Puerto Rico, Avi, was sort of responsible for probably the majority of, where because you have flash loans and you can do other things where you can manipulate the price inside a block, you can do a transfer, and you can also, if a smart contract is dependent upon a price oracle, you can manipulate that price oracle by doing some trades and doing some stuff there. So basically shenanigans you can do against the contract there that may or may, like if you believe the code is law, then it's just good trading. If you believe that regular commercial fraud applies, then you're probably going to be in federal jail. And also just a word of advice is if you're going to do stuff like that, which you should not do, you should also not have child porn on your computer, which is what he did. And so when they raided him for the other thing, they found the child porn material on his computer, and that is why he's still in jail. So, yeah. But yeah, lots of crazy stuff like that.
Yeah, I didn't know about that. And then regarding also this regulatory stuff and technology, CK proofs, zero knowledge. I know you're interested in that. You've been working in that. What's your opinion about that? Where are we going? How does it affect regulation? Does the government want CK to grow?
Yeah, that's one of those. So starting with the end, whether the government wants ZK, the government not being monolithic. Some parts of the government really want ZK because they want to use ZK. Other parts of the government really don't want ZK because it makes their job harder. Other parts want it because having ZK systems in place makes some parts of their jobs harder, but makes a lot of it easier. And they would definitely rather have ZK systems that have some level of legal process built in so that victims of crime can have wallets frozen and things like that, versus systems that are entirely outside of the system. So they don't really have a consistent single view of how that stuff works. But the bigger problem is this stuff is really technically complicated, and we still don't have working systems that really have, like, I think you need to have a really good wallet. You need to have a system that's deployed at a sufficient scale that it can't be like arbitrarily censored by the operators deciding to turn it off and things like that. You need to have the ability to support arbitrary assets. So not just a single underlying artificial token, but you want to be able to support trading between pairs of assets. You want to be able to have stable coins. You want to have all sorts of stuff like that. And you want to have some level of scripting for things like multi-sigs and things like that. No one has all those things together, and you want ZK level privacy. No one has all that stuff together in one system today. And a few systems have it sort of in their roadmap, but it's years out. So this is still open problems in computer science, as well as lots of engineering problems to get it deployed at scale. And it'll be very exciting when it happens. And as we get closer and closer to something that meets all those requirements, it'll be more useful. But I think we're still several years away from having very practical systems there. But yeah, I'm very interested in ZK. The thing that I was interested in Chaumian blinded tokens, which are the same level of privacy as ZK. They just have the disadvantage that each individual server is centralized. So the solution there is you do billions of separate servers, so everyone issues their own currency, and then you have baskets of currencies. That gives you basically the same level of privacy and autonomy that you'd have from a single decentralized system, like a single blockchain that was ZK. So that's an alternative. But when the problem is in 2008, 2009, when Bitcoin was launched, it was a step backwards in privacy by far, because you had existing systems that were potentially Chaumian blinded tokens, which were fully private, just not distributed, not decentralized. But there was a way to make them at least distributed, versus a system that is basically a pseudonym that is strongly maintained and fully linkable, and you can trace all these transactions. And everyone said, oh, but you don't need a KYC to do the purchase, so it's obviously private. And maybe that was true when you were mining your own tokens and you could then do Bitcoin from mined tokens, but still you're linkable on all your transactions. And a lot of people ended up going to jail because they realized after the fact, or the prosecutors realized after the fact, that you can trace stuff just by behavior and tracking. And there's whole companies and whole industries built around tracing Bitcoin payments today. So I think actually there's a lot of people in government that are happy when bad people use crypto as payments because it creates a great audit trail for them, certainly versus using physical bulk cash, and then probably versus using even part of the traditional finance system. It's easier to trace the stuff that goes through crypto. So I think we're still a few years away from having viable ZK systems deployed at scale. We have obviously companies like Zcash or projects like Zcash that have gotten to a pretty decent scale, but actual use is tiny for all of those systems compared to Ethereum, Bitcoin, Solana, the other systems like that.
So regarding privacy and also security incidents, right? Some people say code is law, right? I used to think code was law. Now I don't think that anymore. Because, for example, I don't know, I have a lockpicking set and I could go open your home's door, steal your MacBook from your home, and nobody would say that's okay because I could do it, right? So if we don't think that code is law and we want, for example, DeFi, decentralized finance, to grow and to be massive, we need to do something regarding security, right? And now, for example, we have lots of companies working in Audits, in OPSEC, in different monitoring, or different things that will make the ecosystem more secure. And at the same time, we have lots of people that are following the trail from different attackers, right? To trace the money. So my question is, if we want to be able, my question is, do we want to be able to trace all that money, for example? And what will happen is if in 5 years, for example, we have a really good system, like something similar to Tornado Cash or Monero or Zcash, that makes it really, really, really difficult, or to a point that makes it impossible to trace money. Like, is that something that we want for the ecosystem? And what should we build to give privacy to the people, but not to give tools for criminals, right? Because if we give that, for example, I think that DeFi will for surely fail. What do you think?
I think purely financial crimes are less concerning to me. They're still bad, but they're less concerning to me than crimes that have a physical component. So people paying for terrorist actions, people paying for extortion, things like that apply to physical people, that needs to be prevented at a very high level. But I think it is also very bad to have a system where all of the costs of preventing that stuff are borne by all the people doing regular financial transactions. Like, it is somewhat crazy that if I want to pay a person for a private transaction for, like, paying a babysitter or paying somebody to mow your lawn or whatever else, which today you can do by handing them physical cash. Like, you can't do that in a lot of crypto regimes without having fully KYC'd accounts on both ends. And one of the issues is having to do KYC on your counterparty on those transactions means that everyone that you do business with has to have access to right now in the current system, has access to all of your records and can impersonate you in various ways. And there have been a lot of cases where the transaction itself is not much of a risk. Like, I'm buying an NFT for $100 from somebody, but because of the KYC data that has to be provided to the NFT marketplace, that itself is a much bigger liability than that $100. Like, I don't care if I lose the $100 and they get hacked and you lose the KYC data. So you're basically punishing the good people in the marketplace as well as like an honest participants for the potential crimes of other people. And it's out of proportion to how much the actual risk is there. It's also, there's a case that if it's a global system, there's a lot of things that are illegal in a lot of countries that are legal in other places and are actually viewed as good by people in other places. Like, there's a lot of regimes in the world where a lot of people actively want to subvert them and support people that are fighting against them and things like that. And if you built a system where every government has a veto on every transaction everywhere in the world between every counterparty, almost nothing gets done, because there's books that are banned in certain countries. There's other kinds of transactions that are banned. And you might end up with some places where a transaction is mandatory in one place and banned in another place for the same transaction. And it's pretty difficult there. So I think making sure that the protection against really bad actions is paid for by the right people. So criminals should be punished, not honest people. And there shouldn't be systems that are built, like you don't need to build something that prevents terrorism financing or whatever if the amounts of money involved are very low. Like if it's retail transactions at like for instance, Tornado Cash. The Tornado Cash pool that was used, the 0.1 ETH Tornado Cash pool, was probably not being used to launder the proceeds of very large financial hacks or anything else. In a lot of cases, it was used to pay for like anonymized gas fees for people that are deploying contracts that wanted to be able to do things without being traced. Because one of the crazy tricks that everyone does for tracing stuff is if you want to deploy a contract and you have to fund gas, then tracing the wallet that the gas comes from is usually one of the more profitable ways to trace things. So very small amounts of ETH were being traced for that purpose. And there's a lot of things like that where you're basically it's speech level privacy, which is highly protected in a lot of places, is being prevented because of financial stuff. If every speech transaction you're trying to make where you're posting something required that you provide full KYC, you have no anonymous speech anymore. And there's a long history of people being whistleblowers for crimes, for people for making unpopular political statements. And the problem with all these things that are unpopular today is they might have been fine when you made the statement. Like it might be fine to say something like this government is overstretching its bounds, but then if the government gets more powerful and that becomes illegal to do and it becomes dangerous for you to do, and that is somewhere immortalized on the internet with your cryptographic signature, with your KYC data, then the people come to your house and it's very bad. So it's important to have privacy for not just the laws that exist today, but the laws that could possibly exist in a place in the future. So I'm very cautious of putting too many restrictions on financial transactions because of the potential of them restricting speech, of the potential for them restricting transactions that are objectively good, or that are things that are viewed as good by the majority of people at the time because of what might happen in the future. And I think one of the most effective ways to do this is probably to put size limits on transactions, because most bad activity is much larger scale and much of the good activity is smaller scale. Like most individuals in the world probably don't transact more than thousands of dollars at a time almost ever. Like maybe they buy a house or a car, but most of their transactions are in the tens, hundreds, or thousands of dollars. And those are very large transactions in some cases to them. If you made it so that transactions that are in the $1 million range or the $100,000 range required more documentation than the smaller transactions, that would prevent a lot of problems. And the issue that you have there is aggregation, because you want to make sure that you can't just make lots of $10 transactions and aggregate them and things like that. But if there's a transaction fee involved, and there's a lot of ways to make that system work. And there's also, I don't know, it's mostly a question of which crimes are you most interested in protecting against. And a lot of the crimes that have physical consequences, the most effective way to block them is probably to go after the physical thing. Like for a long time, we didn't, like before telephones, you didn't need to have wiretaps in order to detect people doing whatever conspiracies. You had local stuff. So maybe there's a period of time where internet technology was highly monitorable, and that was used to monitor transactions. Maybe a point where financial transactions were all monitored, and that was used to go after stuff. But maybe we're getting to the point where those aren't the only ways that they can go after these crimes, and they'll have to go back to using other more traditional means. There's been no shortage of confidential informants, infiltrators into organizations. There's no shortage of other technical surveillance that can be applied to people, because it doesn't matter how secure your end-to-end communications are if the endpoint itself has been compromised. And if there's, like, if you're in a room that has a camera looking at your screen, it doesn't matter even if your computer is completely secure, because the monitoring is happening at the local level. So I think they have enough resources. Whenever they target someone, they can usually go after them very effectively. The only exception would be maybe like a foreign head of state or something like that. There they have a lot of protection, but even there, they're largely monitored. Individuals have almost no resistance to that kind of thing. And the main thing that these large-scale technical surveillance things do enable that wouldn't otherwise be possible is broad surveillance of everyone in the population. Like right now, you can surveil all the transactions of everyone in the world, and then you can look for patterns and see what people have purchased and try to criminalize things after the fact there. But the if you had any given suspect, you could go after them and monitor them directly otherwise.
Yeah, and you made me remember something. I don't know if you saw the video some weeks ago from Tucker Carlson saying that when he was planning the Putin interview, he was spied by the NSA that had access to his Signal messages, right?
Yeah.
So what we were discussing on Twitter is, for sure, what happened there is that he had his device owned by the NSA or whoever, and they didn't need to break any encryption code or anything.
Yeah, there's no way that they would reveal that they could break the Signal protocol or the algorithms behind Signal for something like that. That would definitely be an endpoint thing, or even easier if it's in a group chat with multiple people. You have one of the people who's an informant. That was, remember the CZ case where they had all of his stuff, is because they subpoenaed like one of the people who turned like a witness. So if you're in a chat with like 20 people, one of them is likely to be turning over data. Yeah,
so. Totally. And what do you think about developers being detained or imprisoned? The Romans from Tornado Cash, Alexei, and other cases. We were talking a bit about that, and the relation with I think it was 1983 when perhaps you remember the year better, when PGP, for example, was banned from being exported, as you were telling before.
Yeah, so the ITAR restrictions on exporting crypto, where basically cryptography software was treated as a munition, as a weapon, and was governed by the Department of Defense, later moved to Department of Commerce, but still restricted. If you're building a hardware crypto module today, it is still restricted for export, and you have to go through some certain processes for doing so. So there's a lot of those laws that exist that make sense in certain contexts. Like, it makes sense that you can't export like a missile or something else to some country without having a permit, but computer software does not really make any sense to restrict that way, and certainly not computer software that's used for free speech communication by people. PGP, created by Phil Zimmermann, was really the first end user accessible use of public key cryptography, and was used for messaging people. It was very interesting. It was the best system that existed at the time, but it was certainly hard to use, and people put a lot of effort into it. I hate getting PGP mail. I use it to sign code today, so if I'm releasing a package or something, but I hate using it for communications, because today we have Signal, and like, one, email is kind of inferior to instant messenger, and two, Signal has all this stuff built in at the addressing layer rather than having to build it on top of the existing system. So that's just a better system. But I don't know, there's a lot of history of the federal government going after people. They usually don't go after the strongest potential defendants. They go after people that are in the U.S., especially not U.S. citizens, like foreign, especially people from Eastern Europe and Russia that are visiting the United States or otherwise exposed. There was a case with the DVD copy protection issue where there was a Russian software developer who was at a conference that I was at, and that thousands of U.S. citizens were at. A lot of other people that were potentially involved in that kind of stuff that were U.S. citizens who would be much more capable of defending themselves, they chose to go after and arrest and detain a Russian national who was visiting the U.S., and that made it easier for them to do stuff. They can put a lot more pressure on somebody like that. And then in the case of Tornado Cash, the Tornado Cash developers, if they had been U.S. citizens in the United States, would have had probably some additional defenses available to them that were not available due to both the Dutch government, who just like detained somebody with no charges for a long period of time, and in general, like, not being a citizen in the country that you're living in exposes you to more potential routes. Even if they're not, even if you haven't committed a crime, they can just say, we're going to terminate your visa and you get deported. So they have a lot of leverage they can apply to people. So it's
so you're taking the jobs from the local people.
Exactly. Yes. Yeah. So it is if a government really doesn't like you, they have a lot of levers they can pull. And also companies like Apple, like maybe one of the reasons why Apple is not so big on cryptocurrency is Apple has to get every one of their devices approved by FCC. They have to have patent stuff. They have to have import with customs. They're a big company. They have a lot of, if they want to buy a company, there's all sorts of like anti-competitiveness things. If they anger the government, they have a lot of exposure to that. So it's not worth it for them to do anything that really angers the government. If you're a small company like PGP Incorporated, when they were created to build the PGP software, the only thing they did was PGP, so they could stand up to people. They were all U.S. people. They all had very good legal defense because they had a lot of lawyers from. This was back when ACLU was like a very pro-freedom organization, which it sort of is today, but it's less so than it used to be in the past. But they were willing to stand up to that, and there was an organization, EFF, that was also willing to stand up to the government, and a lot of people in universities and other places that would stand up to the government for going after free speech as software. It's also much easier or much cleaner to go after to defend free speech as free speech versus financial transactions. There's a lot more assumption that financial transactions can be regulated than speech, but the cypherpunks group always had the expression that money is speech, so making a payment to someone is expressing your opinion on something, and thus should be protected under the First Amendment. So it's sort of an interesting legal theory that hasn't really been tested yet. But there's a lot of these organizations that were willing to stand up for the free speech ability to publish code, write it in books, and the fact that they were able to write it into a book and publish it and transport it overseas made it very clearly fit into the traditional world of book publishing can't be blocked. And it's one of the things that and political speech are the two most protected, and religious speech are the most protected things in the US. So that made it much easier to defend than trying to make an argument that like this DeFi contract that sort of mixes tokens and things is protected. So they had an easier case. If there was a way to write Tornado Cash into a book, it would be a lot easier to defend it legally than it is as an online service with a smart contract.
That's a very good point. Now I'll change a bit the subject. In Web 2 security, traditional cybersecurity, like I don't know the stats nowadays, but there used to be like it used to be very, very normal that whenever there was a hack or a security incident, there was something related to an employee or an ex-employee, right? So what do you think about insiders and insider risk in crypto or in DeFi, for example? And how do you manage that risk? For example, one question for also to talk about that. Bug bounties, right? Imagine you are the co-founder of the DeFi protocol. I am a programmer, a dev working at your company. My role is to code secure code, right? And if I ever find a bug, I should report it because you pay me for that, right? So would you pay a bug bounty to an employee of your company that found a bug in production or not? Because it's not so easy if you pay him a bug, because perhaps he will be creating the bugs to find them himself. But at the same time, if you don't pay it and he has the knowledge enough, he could try to hack it and convert it into a black hat, right? So what do you think about risk? And how is all this also related to Evertas, right? To what you do, that is managing risk and giving insurance to mining companies and lots of different crypto companies.
Cool. Yeah, so I'm CISO, or Chief Security Officer at Evertas, where we do crypto insurance. And so I get to see both how a lot of these major attacks go down, because we use that as input into what we defend against and what we make sure our customers aren't doing. And then also we get to write standards for our customers when we do underwriting to have protection in place against these kind of attacks. The insider threat has always been one of the biggest issues in organizations. Like there's the principal agent problem, where the person who owns the organization and the people who run the organization have different interests, and the employee insider risk is really there's the one-to-one version of it, which is his principal agent, and there's like the one-to-n version where you have every employee is basically his own agent. And the risk is exactly as you stated. If you treat employees differently than outsiders, then you either privilege them or punish them for being employees. And you can have a situation where you have an employee can add bugs into the system. You have a situation where the employee just passively learns about a bug in a system, and now that you have ransomware as a service services, this doesn't even just apply to crypto. Crypto is obviously interesting because crypto protocols have financial stuff built in. There's basically a bug bounty built into every cryptocurrency where you can exploit it and get money out of it. But even traditional systems, let's say a hospital system where somebody who works at the organization becomes aware of a vulnerability, they can sell that vulnerability to a ransomware as a service provider, which does all the ransoming and everything else. And you have the risk that the employee knows all the details of like exactly how much the organization is willing to pay, who in the organization will make the decisions, things like that. And potentially they could be talking anonymously to some friend of theirs that exists internationally or wherever else to exploit it. And they can guide them through the process and say, oh, you should ask for this much and then you'll get it. And if you have a world where people can make anonymous payments or whatever else, then it's really hard to defend against that. The solution to that is in low trust environments, like where you can, I'm obviously against crime, but crime is actually a very interesting thing to study because they exist in a world of everyone's a criminal, so they don't trust each other because they're all criminals. So if you have an organization like that, you don't tend to have 100,000 person multinational criminal organizations where they all trust each other. You have little tiny groups that are either family based or otherwise based where they don't have to trust each other, or the people who have to be trusted live in direct fear and they're directly monitored by somebody who can monitor things. I would not want to work for a drug cartel because like you get killed if you do something wrong or whatever else. And it's an effective way to control untrustworthy people to make them do things. And you might end up with a system, if everyone is untrustworthy, you end up with a system with that level of control. Maybe it's not the system where people like that level of stuff, but you have much more thorough checking of things. Like there's a rule with, say, nuclear weapons in the US where if you're going to deploy a nuclear weapon, you can never have a single person standing next to that weapon. It has to be multiple people always there at the same time. And you don't get to pick like who the other person is. It's always randomly assigned. So there's at least 2 people involved in every transaction, every approach to the weapon and things like that. And the same thing with financial transactions where you have somebody from like the operations side of the company initiates a transaction and somebody from the finance side countersigns it so that they can't collude and steal money, and you don't generally have risks. So organizations have built up internal controls around this where basically by requiring multiple insiders to cooperate in order to do some sort of theft, it makes it a lot easier to detect that. One, it makes it harder to do the theft. 2, it makes it easier to detect people trying to do the theft. And you always have the risk that if someone's trying to get you to conspire with them to do some sort of theft, they might be an agent acting to lure you into doing something and then report you, or you might report them. So there's a trust problem because if you don't trust anyone, if they're all criminals anyway, they might defect. So building systems like that are probably the solution to insider threat long run. Also making organizations smaller and making systems more inspectable. So if you don't trust people at all, like I'm willing to buy a bar of gold from somebody that I don't trust very much because I can take that bar of gold and melt it and assay it and measure it and know that it's a good bar. I would not buy a complex like a computer from somebody that I don't trust because there's so much internal logic that could be corrupted inside that thing. You don't know what's going on. And it would be better if we made systems more like commodities, like bars of gold that are physically inspectable and everything else, than like complex software products that are difficult to inspect. And I think this is not specific to the world of cryptocurrency. It is definitely a thing with all complex systems where you can't trust insiders, or where insiders might have different agendas, and we need to, as organizations, solve those problems. But the traditional solutions that the finance industry has come up with of having multiple people involved in each transaction, having internal audits and controls so that it's easy to detect things early in the stage, those work pretty well. Another thing that a lot of organizations do is they do background checks. So one example of that, like the ultimate example of that, is probably government background checks like security clearances. That unfortunately does not work all that well, as we've seen in many, many cases. It worked pretty well in the US during the Cold War, where it was basically US versus Soviet Union, and the only real threat was people being like infiltrated from one side to the other. But the modern threat, you had situations like the Private Manning case where somebody was offended at a management decision made by like an immediate superior and decided to like turn over a bunch of data to WikiLeaks, and no background investigation would have detected that. And actually, background investigations had detected a lot of stuff. But in the U.S., you can't do a security clearance on people younger than 18. And if there's no data from that from less than 18. So you've got like a month of data. The other problem is if you have a lot of crypto projects, like you don't know who you're working with. Like they can create some sort of identity, but you're not going to put hundreds of thousands of dollars into doing a background investigation of every single developer in every project, especially if it's an open source library that you depend on. Because one of the problems we have now is like people depend on libraries that are written by third parties that they don't really have any contractual relationship with, and that library might get replaced at any given time, and you're just going to probably deploy the new version of the library, and it's not really going to go through a full audit cycle, and that could be a problem there. So there's all of these things that have existed as risks always, but it's always been harder to monetize those risks. And now that it's possible that you can exploit these things and make money very directly, there's more of a market for doing that kind of stuff. Certainly, we need better tooling. It is good to fix these problems, because problems that exist that are not addressed by that are like unaddressed problems are sort of lying there for someone to deploy and use against you in the future. If you know that they exist and you mitigate them in advance, then they're taken away. So it's good that we expose these things and fix them before they get exploited at scale. But it is very unfortunate to be the first victim of these things. But the biggest problem with security really is not people being the first victim of some new kind of attack. Like the first reentrancy bug that happened in a Solidity contract, very, very unfortunate for those people. But like the 500th person to fall prey to that is kind of on them. So, yeah.
And regarding unaddressed areas, what about common infrastructure risks, right? Because we talked about insider risk, that is something to address, but what about infrastructure?
Yeah, there's a lot of, if you look at, I think Trail of Bits did a really good report that was, I believe, US government funded on how many blockchains have the majority of their nodes running in AWS. So if AWS were to shut off, I think like 100 AWS accounts, you would take out almost all the L1s that are out there today, which is pretty scary. So, and they did that on their own just by having an outage. So there's definitely these like common vulnerabilities there. The other thing, as an insurance company, we like insuring, we like measuring risks, then being able to insure them if we believe they're fully independent, and your risk of like your insider having a problem is completely uncorrelated from the risk of your competitor having an insider problem with an employee. We can insure that because you're probably not going to both have the same problem happen. But if there's a piece of common infrastructure that is shared by all of these things that we don't know is common and has a common risk, then that might exploit and affect everyone. Like we saw the profanity key generator that people were using to create sort of like vanity addresses that was pretty widely, like depressingly widely used, and a lot of keys were generated that way. And if every one of those projects was insured separately, we would have expected that to be independent risk. And in this case, it was not independent risk. Luckily, mostly that was used for like DAO voting addresses and control addresses for actual exploits, but it was still a major issue. So if we had a common, like an exploit in a wallet that was used widely by people, or obviously an algorithm would be the number one thing. Like if there was a like immediate breakthrough in factoring or something like that happened, that would be a vulnerability that applies to a large class of things. But I think the more identifiable things where we see that there's common infrastructure providers that are used by almost everyone, that is probably the number one shared infrastructure risk right now. And then and it's mainly a denial of service risk, but it's also there's various risks there. And then Oracle risks, where a lot of people are using the same Oracle for pricing data, and it affects a lot of smart contracts, is potentially a major risk as well. There's also we've seen bridges. Bridges are pretty terrifying as a class of risk, because there you get the problem of the problems of one protocol and the problems of another protocol. You're exposed to both of them, plus the unique problems that might come from both of them together. And that's really hard to do. And usually that's a unique risk to the bridge.
So what do you think about cross-chain platforms or projects that depend on bridges, right? Do you think that is it possible in the future to have trustless bridges, or in some way to say, okay, we will have a level of security that will say, okay, yes, Ryan will add liquidity to that bridge, or that we will have like really trustless bridges, or that will not work and every blockchain should work on its own?
Yeah, I think there's definitely a market demand for bridging and multi-chain assets and things like that. But exactly how that's accomplished, I would probably prioritize the real security risks we've seen from trustless bridges over the theoretical risks of counterparties and things like that. It's probably safer today to have the same asset issued by a central party on multiple chains than it is to have a trustless bridge between those chains, at least with our current understanding of smart contracts and everything else. And you do have to trust the central counterparty there, and it's less elegant and everything else. And a lot of computer science people, there's the XKCD comic where somebody's willing to spend like 50 hours building an automation system to save 1 hour on a task that they do once a year. A lot of people will do that, but and especially you can sell that as a product to make money and do everything else there. But you're probably better off building a more manual system that has more delays and more human review of those transfers and is just less automatic. Than a system that has the trustless properties, which unfortunately also come through being automatic. If there were some systems that, like maybe we'll get to the point where we can have trustless systems that have delays built in, or trust minimized systems, so something that's not fully trustless but is at least very concrete on what the counterparty can do to you and very obvious when they do bad things to you and there's recourse against them. That's a better system. Like it's certainly undesirable to have to trust a single counterparty to hold your assets and then like potentially give you the assets if they want to give them to you and not have to give them, especially if they can change the numbers and then act as if they don't owe you any money at all. That's a very bad system. But if it's a system where there's an immutable record of how much they owe you and there's a system of recourse if they don't pay and things like that, that's probably a more safe system today than a system that has immutable or it has automatic bridging between chains. That might not be true in the future. I think that's true today with how technology is today, but maybe that won't be true in the future. And it's certainly an area that's worth researching. But yeah, I think the approach that the stablecoins take in multi-chain issuance today is probably the right approach for that.
Excellent. And well, to close, one last thing to talk about. Audits. What do you think about audits nowadays? How they work? And what things perhaps are not being are not having so much focus? Some companies make a lot of focus on saying, okay, we develop a product, we make an audit with an X company, but perhaps they don't have they don't enforce secure coding for their devs, or they don't have life cycle management. What do you think about the whole process of having a secure software?
So first, I think it's great that audits have basically become required by exchanges to list assets. There's been a long period of time before cryptocurrency, no one really did audits of almost any code. There were things like the space shuttle where they did high SEI 5 review of code, but you had sort of code review, but it was usually internal only code review, usually white box code review, and pretty minimal in how it was done. And it was only done for certain software. It was not done for the vast majority of software. Most software, if it compiles and it didn't have bugs that were reported by users in the field, would get shipped. And that largely is how a lot of software is still deployed outside of crypto. We've also seen with the rise of the app stores for mobile platforms, some tests on there, they do fairly decent checking on builds, partially there to protect themselves from people putting malware into the app store, but also they do some basic static analysis and things that are pretty reasonable checks against software. So we've gotten a lot better at this stuff than we were 20 years ago and even 10 years ago. And cryptocurrency is by far the best application of, or the most wide scale, high market penetration of audit within a single industry for smart contracts. Unfortunately, auditing a smart contract isn't that much of a guarantee of the overall system security. It is a necessary but not sufficient step, because almost even if you assume the audit is perfect, which is a very big assumption to make, and completely comprehensive of all the smart contract related issues. There's a whole bunch of issues, the security issues that happen outside of the smart contract, in the deployment of the smart contract, in the all the tools that interact with it, the interaction between different smart contracts, versioning of a smart contract versus data, all sorts of things like that, where even if the smart contract audit were flawless, there would still be a large potential for vulnerabilities. And we've seen every one of that category lose at least $200 million in the last 2 years. So it's really nice that we have smart contract audits, and there's obviously also a lot of variation in how comprehensive they are, in how well they're done. I'm a big fan. So as an insurance company, we have a slightly different need for audits than as a project does. We need to know that the worst possible audit that an audit firm will do is still a pretty good audit, because someone comes to us with an audit that's already been done. We may or may not have heard of the firm before. We need to know how good that audit is likely to be, just based on knowing the name of the firm and their process. And the only real way to do that is to have a procedure that they follow, that they do on every audit, with tooling, with checklists, things like that, and not the sort of the artistic model of audit, or the artisanal model of audit, where somebody is a deep expert in one particular area and reviews it. One of the issues with audits is, like, code is not all the same. There's a bunch of different stuff. So you can have both different languages, you can have different kinds of contracts, different patterns and everything else. And the same audit firm might be really good at like zero knowledge audits for things that happen in Rust, but they might be commercially pressured to do audits for, say, a high volume contract for some other thing, and they might not be as good. There's also, as a audit firm grows very rapidly, in a lot of cases, they might start out with a consistent quality, but they might start putting more and more people on it that are less experienced with the particular areas that they're auditing. So being able to enforce quality standards is a major thing that people pay. Like, that is the thing people pay the large audit firms for the highly regarded audit firms for, is the brand and the consistency. I think every audit firm pretty much can do good work. It's just a question of how good the median, and then how good the worst thing they'll ship will be. And that's been a challenge with some projects. And then also, if a project says we're going to launch in 8 weeks, we're about to engage our auditors, and they start that process and they only have like a couple of weeks, and the audit takes 3 or 4 weeks, and they get the report back, and they're committed to launching, they're assuming there's nothing will be found. There'll be no remediation. So you might end up with a system where they know that there's vulnerabilities and they launch it anyway, or where they don't know that there's vulnerabilities, and they've already launched, and then they do the audit after the fact. And there's all sorts of stuff around timing. And there's obviously commercial pressures for every project, and just adoption pressures. Like, it doesn't make sense to be perfectly secure and not used by anyone. You want to get your system out there and deployed, and you have a finite amount of funds, and you need to hit milestones and everything else. So I understand why people have aggressive timelines, but when someone says we're going to launch in 4 weeks and we have an audit that we haven't started yet, and they are acting as if the audit's completed and has been successful, that's kind of a red flag. So.
Yeah, I agree. Totally. Okay, excellent. I think we have covered lots and lots of issues. We could be talking, for 6 hours. Yeah. For a whole flight between Toronto and Buenos Aires. Yeah. So, one last thing. What would be like the 2 or 3 simple things that you would recommend to any crypto user, even if it's beginner or OG, regarding security? What are the 3 simple things that anyone can do, perhaps do after the show, that will make their security far, far better?
Probably the number one thing I would do is say you should segregate your wallets and have a sort of a play wallet, which has small amounts of money. Just like you have your physical wallet and you keep maybe hundreds of dollars in your wallet, you don't keep tens of thousands of dollars in your wallet that you carry around. And use that to do transactions. Learn how stuff works. Like, it is better to have an easy to use wallet that has $50 in it that you go out and you do transactions with, you experiment, you learn, you have fun, than to have the perfectly secure system that you never use, or the system that puts you at huge risk because it's a high value wallet that is also used for highly transactional stuff. So I would say experiment with low value at risk and try new stuff and use that as a learning experience. Don't treat it as like an investment. Treat it as a learning experience and use small balances there. And In general, I've seen individuals lose more from loss than they have from theft. So you're probably better off being more cautious in replicating your seed phrases in your wallets, things like that, and not losing them than you are in protecting from outsider theft. Like, I would in general be, obviously high value balances, wallets, I would never put my seed phrase into like a password manager or something, but I would be more comfortable having a seed phrase in a password manager that's otherwise well secured than having it on a single piece of paper that is badly stored in one location that you end up losing. So having multiple locations with physical copies is probably the easy thing to do. They don't need to be in like TL60 bank vaults that cost millions of dollars. Just having them in physically separate locations that aren't going to have a single fire that takes them out and are clearly like maybe in like a sealed envelope or something that are protected and like that. But no one's going to break into your house to steal a piece of paper that is worth $100 or $1,000 or whatever. So that's probably not the threat to worry about. So I would generally focus on learning how things work with small balances and on having your systems protected against accidental loss from just like bit rot or losing something physically or whatever else. I am a big fan of using either hardware wallets or hardware protection or things like that, like the secure elements that are built into devices. Some of the hardware wallets and things like that are very nice to use, but I would, for the small value stuff, like I just use MetaMask with a relatively small amount of balance in it for doing routine transactions, and I do more transactions as a result of that. I used to use a hardware wallet for every one of my wallets at all, and I ended up just not doing transactions. Like, it was pretty embarrassing to go to a conference where someone asks you to buy something with ETH or BTC or whatever, and you have to like pull out a wallet and you can't connect it to your phone, so you don't do the transaction. But yeah, so I think segregating your stuff into large balances and small balances is the way to go. And then just learning as much as you can about the things by following. I think Twitter is a great information source. There's a lot of people that write a lot of stuff in blogs, and podcasts are a major information source, and just constantly learning about this stuff is a good way to go.
I love it. Well, Ryan, it has been very, very interesting. I have learned a lot, and for sure everyone that is listening too. So I want to thank you very much. I hope to see you soon. Do you have plans to come to Argentina?
I had plans about a week or two ago, and I unfortunately wasn't able to make it. I will probably make it later this summer, which I guess is your winter, but if not, it'll be in like Q3, Q4. But yeah, definitely I plans to return. I'm going to spend a lot of time in Europe this summer and in Asia, but otherwise, there'll be a lot of conferences.
Well, then we'll see in another conference, perhaps in FCC. Okay, Ryan, thank you very much for everything, and I hope to see you soon.
Cool. Thank you.
Thank you, everyone.
Thank you.
Blockchain Security Series, the podcast where the future of Web3 security unfolds. Presented by pablito.eth.